Okay, so just as an example, we start with this equation, non-homogeneous equation with non-homogeneous part tangent of t. Characteristic solution is this. That's just review. It's not totally relevant, but the fundamental set is relevant, and it's this. And this is all very easy to get nicely. Okay? Now we're going to assume a particular solution to this. That is a solution to this actual equation. As we saw before, you add a particular solution to your general solution or your characteristic solution, and you have the general solution to the equation. Okay, so we're going to assume y sub p of t, p standing for particular, is u1 of t, e to the negative 2t plus u2 of t, e to the negative 3t. Just a linear, it's like a linear combination of your solution set, except it's not linear because these are functions of t. And we want to try to find functions of t, a u1 and a u2, that'll make this expression satisfy this equation. So what do? We plug this expression into the equation. Now we take the derivatives. That's straightforward, but we did this because we wanted to just get warmed up a little bit. Okay? Didn't take long on this. So we found the derivative of yp and the derivative of that using the product rule, and it's all straightforward and obvious. You should be able to ask this of any second semester calculus student, and they'd be able to write it down. And not realistic that they all would, but some would. And you guys probably would have at this point last year. Okay? But since you've forgotten a lot, well, you're doing some calculus, you've done some calculus. I don't think you had any trouble with this. We did a little simplification here where we noted that we had two terms here. Two terms here, the u1 prime terms, that were the same, so we combined them, okay? And then we had a couple of u2 prime terms here that we combined. Well, something similar is going to happen when we write this out generally. So let's now assume that we have this. Okay? This is our equation. We're going to get a fundamental set. And we can certainly do that if these are constant coefficients, and we'll worry about what if they aren't constant later. Okay? So our fundamental set, we're going to assume is we express as y1 and y2 functions of t. And we assume just what we did here, a combination of these, like a linear combination, both a u1 of t and a u2 of t function. Okay? So what do we got? Well, here's our particular solution, and here's our derivative, and here's our second derivative. Again, very straightforward. So I'm not going to go through how we apply the product rule. Very straightforward. Okay, so I'm not going to waste time on the video or in class going over that. We kind of talked about it in class, but it's pretty straightforward. Okay? And then we plug these into the equation. Okay? Now, when I plugged them in, hopefully I did it right. I was pretty careful, so maybe I did it right. Often I'm not careful, and I do it wrong, and sometimes even when I'm careful, I do it wrong. But I think I've got every term accounted for. And what I did was, I only took the first two terms here and wrote down the expression I would get for those, okay, for the y double prime, and the first two terms here. And then separately, I wrote this term plus this term, okay? Now there's a reason for that, and you'll see the method behind my madness in a minute, okay? Then when I wrote down this term, I again wrote these two terms down. Of course, there's a b in front of y prime, so I have those two terms here. And that would be this term and this term. And then I wrote these two terms separately. And then I just wrote down my c times my particular solution. And we can verify that everything here appears to have been plugged into this equation correctly. Okay? And that should equal g of t, of course. And we're not worried about u of t just yet. It'll get worse in a moment. Okay? Now what I just asked you to do was write down all the terms that just have u1 as a factor. Okay? And that would be this term, and this term. And my reason for separating off these two terms, and these two terms is that they're the terms that have u1 or u2 as factors. Okay? Now why is that a great thing? Well, it's because these three factors by themselves give us u1, y1 double prime plus u2 times b y prime plus, and that's not u1, it's u1, not u2, it's u1, plus u1 times cy. And of course now I can factor out u1. And it's y1 prime. Okay, now, I ask you why this has to equal 0. Well, what does this look like? You maybe want to look at the left-hand side of the original equation. What do you see?
Same thing.
And what do you know about y1?
It's a solution.
Yeah, a solution to what?
To the left-hand side.
The left-hand side is just a side. You have to have an equation to have a solution. What equation does y1 solve?
The homogeneous.
Which means it's equal to what?
0.
This is a solution to the homogeneous equation, which sets this thing equal to 0, right? Well, if this is a solution to the equation equals 0, it's got to equal 0, right? So this is a solution to the homogeneous equation, so it's equal to 0. So guess what? These three terms add up to 0. Okay? And guess what else? Same thing is true for u2 and y2. If I just replace the 1's by 2's, this is the other solution to the homogeneous equation. Which means that this and this and something else,
Your B
and
factors.
I left one off. No, I didn't. I'm missing something. Yeah, this. I just couldn't see it. Okay? This, and this are all 0. But doesn't that make us happy? Because now all we've got left is 1, 2, 3, 4, 5, 6 terms. And there's no y1 or y2. Well, yeah, there is. So forget I said that. Okay, but that's what we've got. Okay? So now we can write this equation, and I would proceed to do this. I had a clean board behind here, but I don't. So I'm going to have to stop the video and get something clean to write this on. Okay? In the meantime, I'm going to ask you to write out the equation and ponder it. So, write out what you have left.